Hello everyone, welcome to today's chemistry class. Today we will discuss the topic bond parameters. Here we will see different terms of bond: bond angle, bond length, bond order, bond enthalpy. These are the bond parameters today we discuss. So first of all, we will discuss the bond parameter bond length. So from the heading or from the name of the bond parameter, you can understand that is nothing but length of the bond length. So bond length is defined as the equilibrium distance between the nuclei of two bonded atoms in a molecule. It is nothing but the distance between two nuclei of the two bonded atoms. Okay, so distance between the nuclei of two bonded atoms is known as bond length, and bond lengths are measured by spectroscopic, X-ray diffraction techniques, etc. So it can be measured. It is a very small quantity. ചെറിയതായിരിക്കും bond length എന്ന് പറഞ്ഞാൽ. So bond lengths are measured by spectroscopic or X-ray diffraction techniques. Each atom of the bond pair contribute to the bond length. Each atom of the bonded pair contribute to the bond length. In case of a covalent bond, the contribution from each atom is called covalent radius of the atom. Okay. In case of covalent bond, the contribution from each atom is called the covalent radius of that particular atom. The covalent radius is measured approximately as the radius of an atom. So it is covalent radius is nothing but the radius of an atom's core, which is in contact with the core of an adjacent atom in a bonded situation. ഇപ്പോൾ രണ്ട് ആറ്റംസ് ബോണ്ട് ചെയ്യപ്പെടുമ്പോൾ ഉണ്ടാകുന്ന ആ റേഡിയസ്, ഓക്കെ, ആ റേഡിയസ് ഒരാറ്റത്തിൻ്റെ റേഡിയസ് ആണ് കോവാലന്റ് റേഡിയസ്. അപ്പോൾ മറ്റേ ആറ്റം അത് കോണ്ടാക്റ്റ് ആയിട്ടുണ്ട്. ഓക്കെ, സോ ദ കോവാലന്റ് റേഡിയസ് ഈസ് മെഷേർഡ് approximately as same as the radius of an atom's core, which is in contact with the core of an adjacent atom in a bonded situation. The van der Waals radius represents the overall size of the atom, which includes its valence shell in a non-bonded situation. So the van der Waals radius means the overall size of the atom, which includes its valence shell in a non-bonded situation. Okay. Now we can discuss the bond angle. Bond angle. It is nothing but the angle between two bonds. Okay, two bonded atoms. Okay. It is defined as the angle between the orbitals containing bonding electron pairs around the central atom in a molecule or complex ion. Bond angle is expressed in degree and the small unit is minute and second. Okay. So bond angle is, if you consider CH4, okay, CH4, carbon is the central atom. Carbon is the central atom. So HCH bond, we say HCH bond. Okay, HCH bond angle. Okay, and there is a HCH bond angle. That angle is 109 degree 28 minute. So it is expressed in degree, and in minute is the small quantity. So the bond angle is defined as the angle between the orbitals. It is the angle between the orbitals containing bonding electron pairs around the central atom in a molecule or complex ion, and bond angle is expressed in degree. Now we can discuss the next concept, that is bond enthalpy. Enthalpy means energy. So that also we have discussed, that is electron gain enthalpy, ionization enthalpy, lattice enthalpy. So enthalpy is energy. It is nothing but energy. So bond enthalpy is defined as the amount of energy required to break 1 mole of bonds of a particular type between two atoms in a gaseous state. So it is the bond enthalpy is the amount of energy required to break 1 mole of bonds of a particular type. Okay, അതായത് ഒരു ബോണ്ട് ബ്രേക്ക് ചെയ്യാൻ വേണ്ട റിക്വയർ ആയിട്ടുള്ള അല്ലെങ്കിൽ ആവശ്യമുള്ള എനർജിയാണ് നമ്മൾ ബോണ്ട് എൻതാൽപ്പി എന്ന് പറയാം. ഓക്കെ, so the unit of bond enthalpy is kilojoule per mole. It is expressed in kilojoule per mole, kJ per mole. Example, the H bond, that means the bond between two hydrogen atoms. The HH bond enthalpy in hydrogen molecule is 435.8 kilojoule per mole. It is 435.8 kilojoule per mole. So H2, it is H2 molecule. You have to break H2 molecule into two hydrogen atoms. So that bond enthalpy is, so that the amount of energy required to break a hydrogen bond between two hydrogen atoms is 435.8 kilojoule per mole. Okay. And also the amount of energy required to break oxygen bond between oxygen atom is 498 kilojoule per mole. Okay, so the bond between two hydrogen atom is not hydrogen bond, it is different, that we will discuss later. Okay, now the larger the bond dissociation enthalpy, this bond enthalpy is also known as bond dissociation enthalpy. So the larger the bond dissociation enthalpy, stronger will be the bond in the molecule. That means if the bond enthalpy is high, that means we have to apply more amount of energy, or we have to give more amount of energy to break a particular bond. That means that bond is very strong. So the larger the bond dissociation enthalpy, stronger will be the bond in the molecule. So HCl is a strong bond. So you have to break HCl into H and Cl atom. Okay. And in case of polyatomic molecules, polyatomic, that means more than two atoms, polyatomic molecules. So in a molecule, more than two atoms are there. It is known as polyatomic molecules. The measurement of bond enthalpy or bond strength in the following way. Okay, bond enthalpy. Okay, so in polyatomic molecules, we discuss bond enthalpy in the following way. Let us take the example of water molecule H2O. H2O is broken into hydrogen and OH. So H-OH bond. H2O is broken into H and OH. So that bond enthalpy is 502 kilojoule per mole. 502 kilojoule per mole. And OH is then it breaks into hydrogen and oxygen. That is the second bond enthalpy. That is AH2. Okay. That is 427 kilojoule per mole. So in case of water, we take the average bond enthalpy. So water molecule breaks into two steps. The bonds are broken into two steps. So in this case, we take the average enthalpy. So here average enthalpy is taken. Average bond enthalpy is taken. So average bond enthalpy is equal to 502 plus 427 divided by 2, that is equal to 464.5 kilojoule per mole. So in case of polyatomic molecules, we take average bond enthalpy as we discussed in the case of water molecule. So water molecule, in first step, it is broken into hydrogen and OH. Then OH breaks into hydrogen and oxygen. Clear? Now bond order. In Lewis' description of covalent bond, the bond order is given by the number of bonds between the two atoms in a molecule. Okay, so it is a very simple concept, bond order. Bond order is nothing but number of bonds between two atoms in a molecule. So number of bonds between two atoms in a molecule. So when you take the hydrogen molecule, there is only one bond between two hydrogen atoms. So bond order is 1. When you consider oxygen molecule, only two bonds are there. So bond order is 2. And when you consider nitrogen molecule, there are 3 bonds. So bond order is 3. So for example, hydrogen we have 1. For oxygen, bond order is 2. And for nitrogen, bond order 3. Okay. because in hydrogen we have only single shared pair of electron, and in oxygen 2 shared pairs of electron, and in nitrogen 3 shared pairs of electron. So bond order is the number of bond pairs or bonds between two atoms. Okay. Now for nitrogen, the bond order is 3 and its bond enthalpy is 946 kilojoule per mole, and it is one of the highest for diatomic molecule. So in the case of nitrogen, the bond order is 3 and its bond enthalpy is 946 kilojoule per mole, and it is one of the highest for diatomic molecule because it has a triple bond. So in nitrogen there is a triple bond. Okay. And isoelectronic molecules and ions have identical bond orders. Isoelectronic means a number of electrons are same or the number of electrons are equal. Such species are known as isoelectronic species. So isoelectronic molecules and ions have identical bond orders or bond order ഒരുപോലെ ആയിരിക്കും. Example, nitrogen and carbon monoxide have bond order 3. In between two nitrogen atoms we have 3 bonds, and between carbon and oxygen or in carbon monoxide the bond order is 3. Okay. So a general correlation useful for understanding the stabilities of the molecule is that with increase in bond order, bond enthalpy increases and bond length decreases. So we can correlate these 3: bond order, bond enthalpy, bond length. When bond order increases, bond enthalpy also increases and bond length decreases. Bond length decreases ഡിക്രീസ് ചെയ്യുമ്പോൾ ബോണ്ട് എൻതാൽപ്പി കൂടുന്നു, അതുപോലെ തന്നെ ബോണ്ട് ഓർഡറും കൂടുന്നു അല്ലേ. ബോണ്ട് ഓർഡർ കൂടിക്കഴിഞ്ഞാൽ ബോണ്ട് എൻതാൽപ്പി കൂടും, അപ്പോൾ ബോണ്ട് ലെങ്ത് കുറയും. ബോണ്ട് ലെങ്ത് കുറഞ്ഞെന്ന് പറഞ്ഞാൽ ചെറിയ സാധനത്തിനെ പൊട്ടിക്കാൻ ബുദ്ധിമുട്ടാണ്. ദാറ്റ് ഈസ് ദ മീനിങ്. ഓക്കെ, ദാറ്റ് ഈസ് എ കോറിലേഷൻ ബിറ്റ്വീൻ ബോണ്ട് ഓർഡർ, ബോണ്ട് എൻതാൽപ്പി ആൻഡ് bond length. Okay, so bond order is the number of bonds between two atoms. So today we have discussed bond angle, that means angle between two bonds. Then bond length, length of bond, that means distance between the two bonded nuclei of two bonded atoms. Then bond order, number of bonds between two atoms. Then bond enthalpy. Bond enthalpy is nothing but the amount of energy required to break a bond. It is also known as bond dissociation enthalpy. Okay, bond dissociation enthalpy. In case of polyatomic molecule, such as water molecule, we take average of bond enthalpy. Okay, that is all about today's session. Thank you.